Welcome back. Let's do question 5.4.2. Given the identity cos x plus y times cos x minus y is equal to 1 minus sine squared x minus sine squared y. Right, in question 5.4.1, we managed to prove this. Now the question says, hence, determine the value of y minus sine squared 45 degrees minus sine squared 15 degrees. Hence means we have to use our answer we got here in 541. It means we have to use our previous answer. How can we do that? So that's the easiest thing to do. But there are other ways of doing it. I'm going to show you the other two methods. But it says hence determine the value of this. It means that we have to use our proof. So we prove that cos x plus y times cos x minus y is equal to 1 minus sine squared x minus sine squared y, right? And then now we want to find the value of what? Of 1 minus sine squared 45 degrees minus sine squared 15 degrees. So if you check, we can easily see that the 45 is equivalent to x and 15 is equivalent to y. So we can write this in this form. Where there's x, we can put 45, and then where there's y, we can put 15. So this can be cos 45 degrees plus 15 degrees. And then times cos 45 degrees minus 15 degrees. You see that? And then this is equal to what? Cos 60 degrees times cos 30 degrees. This is the easiest method. You will see that. I'm going to show you the other two methods. Once we use this instruction, hence determine the value of this, then we use our proof. It becomes very easy. These are special angles. Then cos 60 we know is half, and then times cos 30, which is root 3 over 2, right? And then we can say 1 times root 3, which is root 3, then 2 times 2, which is 4. Done. That's the answer there. The other way of solving this will be, let's try to use the other methods. Remember, 1 is equivalent to sine squared x plus cos squared x is equal to 1. Do you remember that from grade 11 identity? Right, so we can replace 1 with this. We can replace 1 with this. And then what we have, so where there's x, we can put what? We can put 15. We're going to leave sine squared 45 degrees because it's what? It's a special angle. Let's try to eliminate sine squared 15 degrees. So we're going to use this. So where there's x, we put 15. So sine squared 15 degrees plus cos squared 15 degrees, then minus, we have replaced this one, minus sine squared 45 degrees minus sine squared 15 degrees. And then sine squared 15 degrees minus sine squared 15 degrees will give us 0. So we're remaining with cos squared 15 degrees minus sine squared 45 degrees. Okay. Right, what we can do here, let's deal with our special angle, which is 45. Sine squared 45 degrees. Remember, sine 45 degrees is equal to what? So remember, sine squared 45 degrees is just the same as sine 45 degrees, then squared, isn't it? So sine 45 is what? Sine 45 is root 2 over 2. So we're saying cos squared 15 degrees minus root 2 over 2 squared. See that? Root 2 over 2 squared. Then root 2 over 2 squared will give us root 2 squared is 2, 2 squared is 4. So we have cos squared 15 degrees minus 1 over 2. Okay, this will give us 1 over 2. And then this is like cos squared 15 over 1 minus 1 over 2. Now let's make the denominators to be the same. So we multiply this by 2. We multiply the denominator by 2 and multiply the numerator by 2. So what we get? We get 2 cos squared 15 degrees over 2 minus 1 over 2, right? And then now the denominators are the same. We can subtract the numerators. 2 cos squared 15 degrees minus 1 over 2. Right, if you check the numerator here, what do you recognize? You should be able to recognize the double angle formula. Remember that. Let's say cos 2x, one of the formula will be 2 cos squared x minus 1. Do you remember that? That's a double angle formula. So it means we can replace this whole thing, this whole numerator, by cos 2 times 15 degrees. It's like where there's x, there's 15, isn't it? 15, 15. So we're multiplying this one, the 15 by 2 there. So we're replacing this with cos 2 times 15 degrees over 2, which is equal to cos 30. Cos 30 degrees over 2. Then cos 30 is what? Cos 30 is root 3 over 2. So it's going to be root 3 over 2 divided by 2, which is the same as root 3 over 2 times 1 over 2, which is equal to root 3 over 4. Okay, that's another method. See how demanding it is. Right, now the last method. Let me erase this to create space. Right, we have 1 minus sine squared 45 degrees minus sine squared 15 degrees. Let me use this space for the other calculations. Right, remember from cos squared x plus sine squared x is equal to 1. We say that sine squared x is equal to 1 minus cos squared x. Or we can say that cos squared x is equal to 1 minus sine squared x, meaning that this can be replaced by cos squared x. Okay, and then our x in this case will be 45 degrees. So we can replace this with cos squared 45 degrees. So it's cos squared 45 degrees minus sine squared 15 degrees. Cos 45 degrees is a special angle. So this is root 2 over 2 squared minus sine squared 45 degrees minus 30 degrees. It will be better if we write this thing like this. If you say root 2 over 2, remember root 2 over 2 will give us 1 over 2, because root 2 squared is 2, then 2 squared is 4. 2 over 4 is 1 over 2, right? Minus, and then if we can write this square outside the bracket, it's going to make our life easy. So let's write this one like this: sine 45 degrees minus 30 degrees, like this, and then squared. Okay, and then remember our compound angle formula. Compound angle formula is in the form x minus y is equal to sine x times cos y minus cos x times sine y. So we can use this. 45 is like our x and 30 is like our y. So it becomes 1 over 2 minus sine 45 times cos 30, then minus cos 45 times sine 30, all this squared. Then these are special angles. So what we have 1 over 2 and then root 2 over 2 times root 3 over 2, cos 30 is root 3 over 2, sin 45 is root 2 over 2, minus cos 45 is root 2 over 2 times sin 30 is 1 over 2, all this squared. And then let's just simplify this. This is like 1 over 2 minus 2 root 2 times root 3 over 4 minus root 2 over 4 squared. Just say root 2 times root 3, which is root 2 times root 3. 2 times 2 is 4. Yeah, root 2 times 1 is root 2. 2 times 2 is 4. And then squared. Alright, so now what we need to do, we need to simplify this part. I think we need to simplify this part. Let's just do it by the side, and then we'll come back to this. So we have root 2 times root 3 over 4 minus root 2 over 4 squared. Now we can subtract the numerators. This gives us root 2 times root 3 minus root 2 over 4, right? Okay, squared. Now we can do things differently here. We can do things differently. But what I may do here is to say, let me factorize this numerator. Becomes root 2 and then root 3 minus 1 over 4. All this squared. And then if we square the numerator, root 2 squared is 2, isn't it? And then root 3 minus 1 squared. Root 3 minus 1 squared should give you, we say root 3 squared is going to be 3 because it's like a square binomial. So root 3 squared is 3, and then 2 times root 3 times negative 1, that is negative 2 root 3, and then you square the 1, you get 1, positive 1. We have squared this part. Okay, if you want, you can use the FOIL method, the long way. Say root 3 minus 1 times root 3 minus 1, and then you expand. It will simplify to this. It will simplify to this. And then over 4 squared, which is 16, right? And then 2 into 2, 1, 2 into 16, 8. And then in the bracket 3 plus 1 is 4. So we have 4 minus 2 root 3 over 8. We're going to replace this whole thing with this. Okay, let's just do that. So it's going to be 1 over 2 minus 4 minus 2 root 3 over 8. Right? If I may break this fraction here, this fraction in the bracket, it's going to be 1 over 2 minus 4 over 8 minus 2 root 3 over 8. I just broke this fraction here into two parts. And then 4 over 8 is like 1 over 2. So 1 over 2 minus 1 over 2 and minus 2 root 3 over 8. Right? Then let's remove the bracket by distributing negative 1. It's going to be 1 over 2 minus 1 over 2 plus 2 root 3 over 8. Half minus half is 0, so we remain with 2 root 3 over 8. 2 into 2, 1, 2 into 8, 4. So we have our root 3 over 4, you see. So if we just follow this instruction to say hence simplify, hence determine this, and then we used our answer, it becomes very, very easy. You can compare the first method with the other two. You'll see how easy the first method is.